Hello, and welcome to Cosmological Arguments. I'm your host, John Bannan. Block universe. In this video, I'm going to explain to you what the block universe is, why it's bad for believers in God, and why it isn't real. So let's start off with what is the block universe? The block universe is a metaphysical concept that derives from Albert Einstein's theories of general and special relativity. It is a mathematical model that those theories use in describing the behavior of physical reality. Generally speaking, it's called a block universe because it has the general shape of a block. And it looks like this. So this is a depiction of the four-dimensional block universe, this theoretical block universe, which consists of space-time, that is the three dimensions of space, that is length, width, and height, as well as the added dimension of time itself in this four-dimensional conglomerate people call the block universe. The block universe begins with the Big Bang, and it represents the universe as it expands and proceeds through the dimension of time. So this is the forward arrow of time. And as the universe expands and time goes by, the universe gets bigger and bigger and bigger and bigger. And the present reality is what's called a hyperplane of space-time, which is essentially a slice of the block universe. Okay, a hyperplane. So imagine a slice of this four-dimensional block universe, which would be a three-dimensional slice, which would be the present moment of time of the entire universe, but in a frozen still frame. So if you can imagine the whole universe just stopping, like that would be a slice of the block universe. So the idea is that the universe consists of the stacking of hyperplanes of space-time over time. And that stacking is what creates time. It's what creates change in the position of energy and mass and matter in the universe over time. So it's essentially, the block universe is a picture of change as opposed to a changing picture. So it's a picture of change of what undergoes in the universe. So in a block universe, any moment of time is represented by a hyperplane of space-time. So in a frozen moment of time, a hyperplane of space-time, there is no time in that. There is no change. So the change occurs as each hyperplane, as you go from one hyperplane to the next hyperplane through time, that's how change occurs. And in the block universe, time itself is considered an illusion or a trick of the mind. It's really just these slices, these hyperplanes stacked upon each other. And it's just the fact that they're slightly different from each other. And that's what creates the illusion of time and the illusion of moving objects, even people. When the truth is, we're just slices of the fourth dimensional block universe. So is that true? Is the block universe real? And that's an important question. And a big reason for the importance of that question is because it has a big impact on whether God exists or not. The block universe is a very, very, very bad thing for people who believe in the existence of God. And the reason for that is God is the creator of physical reality. That's how God is defined in the first line of the Bible, the creator of the heavens and the earth. So God creates physical reality. So if there's a physical reality that does not need to be created, then you take that creation role away from God and you eliminate a major reason for why we believe God is real. So if this block universe is a real thing, it's bad news for God because you can generally interpret this thing as not requiring a creator, God, in order to exist. So, more about the block universe. What are we in the block universe? Essentially, we are just a moving change through hyperplanes of space-time. We have a beginning point and then an ending point. So we're just what's called a geodesic in the block universe with a distinct beginning and distinct end. In the block universe, the past, present, and future are all equally real. The reason you don't see the past or the future is because your present moment, those things aren't contained in it, so you don't see it. But under the block universe, they're right next door. It's just that since your present moment isn't in that house next door, you don't see the interior of that house. Um, but block universe very much says that all of time, from the beginning to the end, is equally real. It all exists right now, even though you can't see it. So the block universe comes from Einstein's theory of relativity. It's a mathematical model. It's based on tensor calculus, which is what they use to formulate laws of physics under general and special relativity. So it's a very successful mathematical model. Einstein hasn't been wrong one time in over 100 years in terms of the theories of general and special relativity. So it has a lot of credibility. But only the mathematical model needs to work. The mathematical model doesn't actually have to exist in physical reality in order for the laws of physics described by that mathematical model to make accurate predictions in reality. Many people simply assume the block universe is real because relativity works so well in predicting our laws of physics. So they assume the mathematical model must be correct. But that's an assumption. It's an assumption. And I'm going to explain to you why it hasn't actually, the block universe hasn't actually ever been proven to be scientifically real in physical reality. Now, the block universe is supposedly a higher dimensional object. So this is not something that you can see. There's nowhere you can travel to and be in a realm where from some vantage point you could actually observe this thing. This thing is unprovable in that sense. You can't travel to a higher dimension. You can't travel outside the universe. That would be a violation of the conservation of energy and mass, because for you to leave the universe, your body would have to disappear. And that means the universe would suffer a net loss of mass and energy, that is your body, which would be a violation of physics. So you can't leave the universe. So there's nowhere to go to actually verify that this thing is real or to see it. This is a hypothetical metaphysical object. No one's going to be able to take a picture of this. So Why do so many people believe it's real? Good question, right? Okay, so moving on. Why is this so bad, the block universe, so bad for belief in God? Well, many people essentially use the block universe as a substitute for God. If God is the creator of physical reality, then if the block universe exists, you can say, well, the block universe is the creator of physical reality. It's the creator of the universe. And if you can show that the block universe itself doesn't require a cause or doesn't require its own creator, then you've just eliminated God and you substituted the block universe for God. And of course, the block universe is not God and not worthy of worship and not intelligent in the least bit. So this proposition that the block universe is essentially a substitute for God is something that atheists love, and theists should despise that idea. Um, in a block universe, time goes in this direction, forward in time. That's called the arrow of time. So we experience that in our present reality, where we always go to the future and we don't travel to the past. However, in a block universe, there is actually no mechanism at all that says you must go in one direction. Actually, the block universe is bi-directional. So one of the problems with the block universe is if you think of it as bi-directional, then you have a situation where you can argue that it is a self-created or self-caused thing. And if it's self-caused, it doesn't need a God to cause it. So the argument would be, look, you can go in either direction in the block universe. You can go from the Big Bang forward, and you can go from the end of the universe, a Google years from now, back to the Big Bang. So you can argue that because the block universe is bidirectional, that the the past causes the future, and the future causes the past. So you can make the claim, provided the block universe is itself subject to time, that it's a self-caused entity, that it this bidirectional nature, where the past causes the future and the future causes the past, is all that you need to explain causation of the entire block. And if that's the case, you don't need a God to cause a block universe. Now, of course, we know that there is only one direction of time. We experience it ourselves. And the second law of thermodynamics confirms that, since the universe always heads towards a higher state of entropy, that is, disorder, it never goes in the reverse, where things become more ordered over time, and in a closed system, that is. So we have a very strong proof that it only has one direction of time, therefore it couldn't be a self-caused entity. But technically, there is no mechanism that requires one direction in time. So technically, you can make the argument that it also goes backwards. And even though this doesn't make a lot of sense, in a way you can think about it, because how would you know you were going backwards in time? Because you would only know, even if you were going backwards in time, your present experience would only know what you learned, what was in your brain from the past. You wouldn't be able to tell you were moving backwards in time. So there's an argument to be made that it is in fact bidirectional, and that leaves an argument that it is a self-caused or self-created entity, which does not require a God. Now that assumes that the block itself is subject to time, which is a big assumption because it's a fourth dimensional object. So is it subject to time? Well, who knows? Because no one's ever gone to the higher dimensional realm to see what it's like, or to even see this thing, and or yet to tell you whether there's time there. Who knows whether there's time there? Let's assume there is time because there's time down here. In which case, this could be a self-caused thing. But in a fourth dimension, you could also argue that this block universe has its own block universe, one level up in dimension, called a infinite block multiverse. So you could argue that the block universe is just one block of an infinite number of block universes in an infinite block multiverse. And that, if that doesn't require a creator for the same reasons this doesn't, then this doesn't require a creator. So you can move it up one level if you wanted to and propose this infinite block multiverse. However, of course, can't prove this exists either because you can't leave the universe to see this thing if it exists. It's a hypothetical possibility, but there's no way to go take a picture of it. You can't leave the universe to do that. So, as a self-created entity, this doesn't require a god. That's bad for theists. Now, theists can always say, "Oh, but there's a Big Bang. Doesn't something have to create it because there's a Big Bang?" And that's good circumstantial evidence that something does have to, in fact, create a block universe if the block universe itself is real. So you could always say, well, block universe has to be created by something. No, they'll say, well, it's self-caused. And you'll say, well, it's got a Big Bang for a reason, so it must have had a beginning, and that means there must have been a cause to the beginning of it, which means there must be a God in order to cause the block universe to exist. You can make that argument. Now, even if you don't think of the block universe as uncaused or self-caused entity, you can also look at each hyperplane and claim that those are uncaused. And if each hyperplane is caused, then obviously the accumulation of all those hyperplanes would also have to be uncaused. So if the hyperplane is uncaused, then the whole block universe must also be uncaused. And you could say each hyperplane is an uncaused thing that just so happens to be real. And there just so happens to be all these hyperplanes which are similar to one another, which allows us to feel as if we're going through time or creates this illusion of time. But because there's no time existing on any particular hyperplane, there's no reason to say that it's actually caused. The hyperplane itself is caused. So you can argue it's not caused by the abutting hyperplanes either before or after it. That's another argument to make that the black universe itself is uncaused. And if it's uncaused, it doesn't need a cause. It doesn't need a God to cause it. And that would be an argument that God doesn't exist. So in a hyperplane, in a black universe where all the hyperplanes are said to exist at once, the past, the present, and the future, they all exist. They're all equally real. They all exist at once. Um, then the hyperplanes can't be contingent upon one each other because they all exist at the same time. One can't cause the other because they're all present at the same time. So that's an argument that they're uncaused. So they're not. Each hyperplane is not caused by its neighbors. They just all exist at once. Therefore, they do not have. They're not caused by each other. Or you could say the whole block universe has to be created at one time. You can make that argument, the Big Bang. But you can see how an uncaused hyperplane creates an uncaused black universe, which creates an atheistic argument that God doesn't exist. So the block universe is not a good thing for theists or believers in God. It's not. But the good news is there's no scientific proof that this is real. The block universe is a mathematical model. Uh, Mathematical models don't always represent physical reality, the truth in physical reality. And in fact, you don't actually need a block universe. All you need are set deterministic laws of physics that are applied to the present moment of time in order to create the next moment of time. So you're turning the present moment of time into the next moment of time through set deterministic laws of physics. That's all you need to create the universe. You don't need a block universe. However, if you just have set deterministic laws of physics converting the present moment into the next moment, then you need a God in order to create that transformation, in order to create those laws of physics, in order to get the universe to expand. There has to be uh, an unmoved mover, a God that is changing the actual present universe into the potentiality of the next moment of the universe, actualizing that potentiality. So the good news is you just need set deterministic laws of physics and a God, and you can do the same thing as the block universe. Now, uh, I've done some videos on some cosmological arguments which attack the block universe pretty persuasively, and you should feel free to look at those, such as the argument for cosmic or the argument from cosmic information, the argument from caused physics, and the argument from flawed physics. Look at those arguments, and it'll explain to you why the block universe isn't real, and how set deterministic laws of physics are all you really need in order to create present reality. So the block universe is really a redundancy. It's unnecessary. All you need is the set deterministic laws of physics, the principle of conservation of information, and a God in order to expand the universe and cause all of this to happen. Uh, and to conserve cosmic information, and you don't need a block universe to conserve cosmic information through every hyperplane of that block. In addition, it doesn't need to be done twice; it only needs to be done once. And since we know that set deterministic laws of physics exist in reality, then that clearly indicates that that's what's conserving cosmic information, and this would be redundant. We don't need this, and this can be eliminated as an additional unnecessary assumption under Occam's razor. Okay. All right. So, what exactly is the scientific evidence that the block universe is real? Uh, there are a lot of people who assume that the block universe is real because they've been taught that it's basically real in physics class or by others. A lot of people assume it's real. But the truth is, it's a metaphysical concept. It's never been proven scientifically to be real, and it isn't real. So, what exactly is the scientific evidence that the block universe is real? Well, there isn't a lot. Um, what there is derives from uh, strange, relativistic, and quantum behavior in physical reality. So, under, for instance, Einstein's general and special theories of relativity, there are certain relativistic phenomena, such as time dilation, uh, and length contraction that occur when you go near or close to the speed of light, or you go near a massive body that has a great deal of gravity curving space time around it. And then there's also something called the relativity of simultaneity. Now, of those three things I mentioned, the real evidence for the block universe is the relativity of simultaneity. Now, the relativity of simultaneity is a result of Einstein's uh, special theory of relativity. And it is extraordinarily complicated and abstract. So, this is a difficult thing to understand, but I will try to explain it as best I can. Um, the relativity of simultaneity talks about um, two simultaneous observers or events in one plane of space time, and it talks about um, how two observers in different hyperplanes of space time will observe the simultaneity of an event. Okay, so there's this law in the universe that says you have to preserve causality for all observers. So if A causes B, then that will have to hold true for all observers in the universe. They all have to know that A caused B. You can't disrupt causal connections like that, because that would be a disruption of the principle of conservation of information. But there's also, and as a result of this, there's also this rule that nobody can exceed the speed of causality in the universe, which is the same as the speed of light. So the speed of light, or the speed of causality, has to be the same for every observer in the universe. And there's a difficulty there, though, because ordinarily, if, let's say, I'm traveling 20 miles an hour in a car, and I take a baseball and I throw it out the window at a bystander standing on the side of the road. That ball is not going to hit them just with the force of whatever I throw it at. It's going to hit them with the force of whatever I throw it at, plus the 20 miles an hour that I'm driving. So it's going to hit them a heck of a lot harder than I could normally throw it. So my relative speed to the observer is added to the speed or the velocity of the baseball that I throw out the window. That's the case with everything in the universe except light. The speed of light doesn't follow that rule. So if I were to take a flashlight, I'm driving in a car and I'm going 20 miles an hour, and I turn that flashlight on at a bystander on the side of the road, the light coming from that flashlight is not going to hit that bystander at the speed of light plus 20 miles an hour. It'll hit that bystander at the speed of light. And so you can't add to the momentum of the speed of light. So the speed of light is constant for all observers in the universe. And the reason for this is because of the law of conservation of information, and the speed of causality is to prevent disruptions in causal events. So the speed of light has to be the same for everybody, or causality itself would break down. And the universe isn't going to let that happen. So the speed of light, for instance, is the speed of a photon. A photon is a particle of light. And a photon itself does not experience time. And the reason for that is because a photon is actually at a standstill in the dimension of time. It doesn't move through the dimension of time. We move through the dimension of time, but a photon does not. It's at a standstill. So that's why it doesn't experience time. So photons can't experience time, and so they have to be the same speed for everybody because they're standing still. You can't get any slower than standing still. And if you could go faster than the speed of light, which you can't, but if you could, you would have to go slower than a standstill, which would mean a negative speed, which would mean you'd have to go backwards through the dimension of time, which means you would have to go backwards in time. But the problem with going backwards in time is it's impossible. And it's impossible because if you go backwards in time, you could change events. You could disrupt causality. And the universe won't let you do that. So everybody in the universe, if A causes B, everybody in the universe has to see that A causes B. You're not allowed to go backward in time and change events so that A no longer causes B. So because of the speed of causality, the requirement that all observers see the same causality, which is really a result of the principle of conservation of cosmic information, then the speed of light has to be the same for everybody. Otherwise, you go backwards in time. So because the speed of light has to be the same for everybody, the universe has to accommodate that. And it causes all sorts of weird phenomena, one of which is the relativity of simultaneity, along with length contraction and time dilation. So this is all a result. These strange phenomena, relativistic phenomena, are a result of the speed of causality and the need to preserve causality. So the relativity of simultaneity. There's a famous physicist. His name is Roger Penrose. He was a partner with Stephen Hawking in England, and he came up with this thought experiment called the Andromeda paradox. So I'll explain that to you, and then I'll explain to you what's wrong with it. Roger Penrose came up with this thought experiment called the Andromeda paradox, and he said, well, imagine there are two Earthlings, and they're walking past each other one day at about a speed of 5 meters per second. And one of them happens to be walking in the direction of the Andromeda galaxy, and the other one is walking in the direction away from the Andromeda galaxy. Now, because of the relativity of simultaneity, each of those passers-by, because they have a relative velocity to each other, they have their own hyperplanes of simultaneity. And so he's saying, well, they each have their own hyperplane of simultaneity since they have relative velocities. And let's assume that that hyperplane extends out to the Andromeda galaxy, which is 2.5 million light years away. So each of them is on this hyperplane of simultaneity, extending out to the Andromeda galaxy. And because that hyperplane is so distant to the Andromeda Galaxy, the time differential is about 15 days, which means that for the observer moving towards the Andromeda Galaxy, he's saying at that very moment, there was a galactic invasion fleet that was taking off to invade Earth. But for the other observer going away from the Andromeda Galaxy, what was occurring on or in Andromeda at that very moment of time on his hyperplane of simultaneity was 15 days earlier. So the decision to invade Earth had not even been made 15 days earlier. So his question was, well, these two are right next to each other, going in different directions, and yet for one, the fleet has already taken off from Andromeda, but for the other, the decision to launch hasn't even been made. It's 15 days away. So, is there any doubt that the decision to invade has been made and that it's pre-fated or predetermined that this fleet will take off to invade Earth, even for this one observer who's walking away from Andromeda and who's 15 days earlier than the actual taking off of the fleet? So for that person who's walking away, does it make any sense to say that the future isn't set in stone for that observer, that the decision to invade will in fact be made and there's nothing he can do to stop it, that it's set in stone? It must happen because it's happened for the other observer. So his point is that the future is predetermined. It's set in stone. You can't change it. And he uses this as proof that the block universe is real. Because in the block universe, there's hyperplanes, and some of them are in the future. And he's saying, well, they must really exist in order to explain how it is that you could have one person at the moment of launch and another person 15 days earlier from that launch being right next to each other. The only way that makes any sense is if the future is determined, absolutely determinate, and for both of them. And that means a block universe, according to Roger Penrose. Now, the Andromeda paradox is an interesting thought experiment, but there's a problem with it. First initial problem with it is a block universe has an extent in time going from the Big Bang to the end of the universe, which is about a googol years. That's 10 to the power of 100 years until it ends in heat death. So even a 15-day time differential is practically nothing compared to a googol years. So a 15-year differential doesn't itself prove the existence of a block universe. At most, it would prove the existence of a very thick present reality of approximately 15 days. However, there's something even more fundamentally wrong with the Andromeda paradox, and that is that Roger Penrose uses a global hyperplane in his example. He uses a hyperplane of simultaneity that extends from the planet Earth all the way to the Andromeda Galaxy, 2.5 million light years away. Well, that's wrong. In special relativity, you're not allowed to use global hyperplanes. Special relativity is a local theory. It only applies to local regions of space-time. So it doesn't apply to a global hyperplane that extends all the way out to Andromeda. So Roger Penrose used the Andromeda example because he wanted to puff up the time differential, but he didn't tell you that he was using a global hyperplane, which he's not allowed to use under special relativity, and he should know it. And he didn't even prove that a global hyperplane is possible. Now, for example, you could say that, well, in the Andromeda paradox example, instead of a fleet invading, let's use a supernova exploding. So in the Andromeda galaxy, imagine a supernova goes off. Boom! A giant explosion of a star occurs. And the telescopes on Earth will be able to pick up the light from that giant explosion 2.5 million years later, but they'll be able to pick it up nonetheless. So that's basically the same thing as a galactic fleet taking off to invade Earth. It's an event that occurs in Andromeda. So you can imagine the Earth, and you can imagine the Earth rotating, right? And you can imagine, let's say, two Earth-based telescopes. And you can imagine the Andromeda galaxy up here. And as the Earth spins, one telescope is heading in the direction of the Andromeda galaxy, and one is moving away from the direction of the Andromeda galaxy. So you can imagine a supernova going off in the Andromeda galaxy, and its light coming to Earth and being detected by those two telescopes, one of whom is moving towards the Andromeda galaxy and one of which is moving away from the Andromeda galaxy. So just like these two Earthlings on Earth were walking past each other at 5 meters per second, you could think of two telescopes basically doing the same thing in their relative position in space to the Andromeda galaxy. But the question is, would they detect the supernova 15 days apart? No, of course not. I bet you anything that those two telescopes are going to detect that supernova almost instantaneously. There won't be a 15-day delay. And the reason is because you can't use global hyperplanes in the relativity of simultaneity. And that's why Roger Penrose's Andromeda paradox is nonsense. It's wrong. It's wrong on its physics. So the relativity of simultaneity is a real phenomenon, but it doesn't create this 15-day time differential out to Andromeda because it uses a global hyperplane. So special relativity doesn't apply. Now, if you moved the Andromeda paradox, let's say to Mars, you use the same setup, but it's a Martian invasion instead. Same thing, two observers on Earth. Their hyperplanes extend to Mars this time, a much closer planet to the Earth. What would be the time differential if that was the case? Well, guess what? The time differential would be 8.3 microseconds. So assuming that you can have a local hyperplane that extends out to Mars, and I don't know whether you can or not. Maybe that's even too far. I don't know. I don't know if anybody knows how the full extent that a hyperplane can extend as a local region of spacetime. But let's just say Mars. The time differential between those two observers would be 8.3 microseconds. So for one, the decision to the launch is occurring practically at the same moment for the other one when they're walking past. So this is a very, very, very short time differential. And one of the issues with the Andromeda paradox is that it seems to deny free will. I mean, if the decision to invade Earth has been made for somebody, even though they're not on the hyperplane where that doesn't occur for 15 days, then that shows that the decision itself is set in stone, that there's no way for that not to be decided, which would mean you don't have free will. You don't have the ability to decide something else. It's fated. It must occur. Decisions must occur in the block universe, which would deny free will. So, but does 8.3 microseconds deny free will? And the answer is no, it doesn't. The speed of a thought in one's mind is about 150 milliseconds. One hundred 50 milliseconds is about 18,073 times slower than 8.3 microseconds. What this means is, if you take the Andromeda paradox and you put it on Mars instead, it means that the time differential between those two observers is so fast that you can't even think that fast. In fact, it's 18,000 times faster than you can think. Well, if it's faster than you can even think, then it can't possibly deprive you of free will because you can't even think that fast. You haven't even decided anything yet in 8.3 microseconds. So how could that deny you free will? And the answer is it can't. So the relativity of simultaneity is something that happens in a fraction of a second. It doesn't affect free will. And it certainly doesn't prove a block universe. Well, what it proves is there's a fourth dimensional quality to the present moment of time for a fraction of a second. That's all it proves. And it doesn't need to be any faster than that. So its whole purpose is satisfied in a fraction of a second. So if its purpose is satisfied in a fraction of a second, then why would it ever extend to an entire block universe of Google years? It wouldn't. It wouldn't. There's no rational or logical reason why it would. So at most, the relativity of simultaneity proves that the present moment is micro thin. It does have a fourth dimensional quality, but it's only a fraction of a second. And it's certainly, and it does its job in that fraction of a second. And there's no reason to believe that it extends the full supposed block universe of 100 Google years. So relativity of simultaneity does not prove the block universe. Not at all. So is there anything else that proves the block universe or might prove the block universe? Well, there's only one other thing I can think of that you could argue, and that is quantum entanglement. Now, quantum entanglement is this very strange phenomenon in quantum mechanics, which Einstein called spooky action at a distance. But it's real. It's real. So in quantum entanglement, you can take particles such as a photon of light, and you take two of these particles and you entangle them. Essentially, you give them the same quantum state. You take these entangled particles and then you separate them. And in quantum entanglement, once they're separated, if you measure one, you know what the outcome of the measurement for the other one will be. And it doesn't matter how far apart these particles have traveled. or how long in time it's been since they've been separated. They could be half a universe apart from each other. You will know that if you measure one, and let's say you measure its spin and you get a certain result, you know that if you measure this other one, you will get that result. And this doesn't happen in quantum mechanics because things have a probabilistic nature. So any individual thing, there's only a probability that you will get a particular measurement. But these quantum entangled particles, they correlate perfectly with one another. So they're not this probabilistic nature. The determination of one determines the other one. So the question is, well, how does the other one know what the measurement on this one was? How does it know? They could be half a universe apart. You measure this one, you measure the spin, you find out, okay, and then you measure this one, turns out it's exactly the same. It's fated to be that way. How does that happen? Is there some sort of communication that goes on between these two parties so this one can find out what this one is doing? No, there isn't. They can be a half a universe apart, where there's no way that communication could occur because of the speed of light. There's no way that this could communicate fast enough to get all the way over here to tell it what spin to be on the measurement. So it's an instantaneous action at a distance. So what's the explanation for quantum entanglement? Well, somebody who likes the block universe will argue that, well, the explanation is something called superdeterminism. And what that says is that all causes and effects, they're correlated at the Big Bang, at the beginning of time. And everything proceeds in a deterministic fashion and it doesn't change. The outcomes for everything are predetermined, pre-fated. And the reason this other particle knows what this measurement's going to be, because that correlation was created at the beginning of the universe, at the Big Bang. So when it first came into existence, it already knew that this measurement was going to occur and what the outcome was going to be. Therefore, that outcome was cooked into that particle as well. So it's called superdeterminism. So everything is fated. You can't change anything. The future is going to proceed as it proceeds. You can't change the future. You can't change the past. You can't change the present moment. And there's certainly no such thing as free will in a superdeterministic universe, unless there's a God. So that's how you would explain quantum entanglement. And they would use the idea of superdeterminism to say, aha, see, the block universe must exist. All these hyperplanes of space-time must exist in order to set the future in stone so that something like superdeterminism could occur. So that would explain quantum entanglement. So one could argue that quantum entanglement proves the block universe because two particles could be separated in an immense amount of time or across an immensity of the universe, enough to prove a significant portion of a predetermined reality, enough to convincingly show that a block universe is real. Okay, so what's the problem with this argument? Well, it doesn't prove the block universe. It could prove superdeterminism, but you can get superdeterminism without a block universe. And to get superdeterminism, all you need is, again, set deterministic laws of physics and a fixed amount of cosmic information. Those two things, where the present moment creates the next moment, even though there's no block universe, provided that all the information is conserved through set, fixed, deterministic laws of physics, you create the same situation of superdeterminism. In other words, nothing can change. The superdeterministic laws of physics make sure that nothing changes. But you don't need a block universe, technically. And because we do have fixed laws, fixed deterministic laws of physics, that highly suggests that we don't need a block universe. It would be redundant. Cosmic information and superdeterminism can be created by the laws of physics and the principle of conservation of information without a block universe. You don't need it. And the fact that the laws of physics are so deterministic proves that that's what the universe is doing. It doesn't need to be a block universe to have superdeterminism. So that's your way out of the argument of quantum entanglement being evidence of the block universe. Now, superdeterminism causes a problem with free will, of course. If the future is fated to be a certain way and there's nothing you can do about it, then it's difficult to argue that you have the free will to decide something because it's going to be fated into the future whether you like it or not. You won't know what it is, so you have an illusion of free will. But I mean, realistically, if your future behavior is set in stone, I don't know how you could say you have free will. But on the free will issue, there is an argument that God could give you free will. God could let you borrow his free will. God is the only source of free will there is. God has no causal chains or explanations attached to him because he's a divinely simple being. If he causes thoughts or consciousness in you through a miracle, essentially in your brain, you could borrow God's free will in a sense. Because God doesn't have causal chains, then one could say that God's direct intervention in your mind doesn't have a causal chain either. So you might as well just say it's you're causing it. So it really is your free will borrowed from God. So that is a possibility. However, that would involve a miracle in your brain, and that would be a violation of the laws of physics. But every miracle is a violation of the laws of physics, and that would be creating new information in the universe. But the rest of the universe would be proceeding under set deterministic laws of physics. So there is a way to still get free will even under super determinism. So don't worry about the free will issue. But do understand that superdeterminism can be explained without a block universe. It's not proof of a block universe. Okay, so there it is. The only real scientific evidence of the block universe is quantum entanglement and the relativity of simultaneity. And I've explained to you why both of those do not prove a block universe. So there is no actual scientific proof for a block universe. And as a theist, trust me, you don't want there to be a block universe. So argue that the laws of physics as set deterministic laws and the conservation of cosmic information is enough. And you don't need a block universe, which is redundant, and you can eliminate it under Occam's razor as an unneeded additional assumption. Now, it's amazing to me that so many people just assume the block universe is real, despite the fact that there's no scientific proof that there is. There's a little bit of this scientific evidence, but that scientific evidence can be explained away quite convincingly. So remember, the block universe is not real. It's a metaphysical concept. It's a mathematical model based on Einstein's theories. But just because Einstein's theories have been outstanding in predicting physical reality does not prove that the block universe is necessarily real. It doesn't prove that. The whole thing could be done by God through occasionalism. God could create every moment of time, every present moment of time, however many hyperplanes of simultaneity you require in any given moment of time, annihilate it all and create the next moment. If God has control over everything that happens in the universe, every particle of matter, everything, for every given moment of time, he can make the universe appear any way he wants, even if it gives the impression of comporting with a mathematical model like the block universe. But occasionalism lets God to do whatever he wants. So that's the much better philosophy of causation for a theist, occasionalism, and avoid the block universe at all cost. All right, so I hope you learned something. If you get a chance, check out my new book. It's called The Encyclopedia of Philosophical Cosmological Arguments for the Existence of God, written by me, John Joseph Bannan. The Encyclopedia of Philosophical Cosmological Arguments for the Existence of God, written by John Joseph Bannan. You can find it on Amazon. You can read it on Kindle. Please check it out. It explains the cosmological arguments, and it gives a lot of detail and explanation of those arguments, as well as what I essentially presented in this video is also in that book. And it has a lot of interesting philosophy in it as well. I'll put a link to the book in the comment section of this video for your convenience. All right, so I hope you learned something. And if you're a theist, don't ever admit to the block universe or an infinite block multiverse. Take care.